Well, mm, continuing our detour into how we formulated notions of space and time from different approaches, whether it was philosophy, whether it was mathematics, and now we are coming to physics part of it, mm, the 20th century physics. So it covers a very interesting era, the departure from Newton to Einstein. It's more than 300 years. So the 300 years, the kaleidoscope or the landscape, how the notions of space and time, it is the way it is being formulated. It's not less than a revolution in our understanding of things. But the more important point which Iqbal wants to say is that he wants to contest is that the sort of materialism which was sort of necessitated by a particular viewpoint of space-time as seen in Newtonian worldview. So it was somehow questioned in that sense by the incoming of new notions of space and time in that sense. For example, so before even trying to come how we arrived at that, for example, Iqbal says with Einstein, space is relative, real, but relative to the observer. He rejects Newtonian concept of an absolute space. The object observed is variable, it's relative to the observer, its mass, shape, and size change as the observer's position and speed change. Movement and rest too are things relative to the observer. There is therefore no such thing as self-subsistent materiality of classical physics. So that's it. So before we are going to contest the absolutization of space, notions of space and time, which was a particular viewpoint of Newton. In the background of how Leibniz also tried to see the relative notions of space and time, and the famous debates of famous debate of Newton with Leibniz. Newton through his pupil clerk, how they basically tried to contest this notion of space and time vis-a-vis a certain theology, vis-a-vis how we can, whether omnipotence of God is being somehow in the Leibnizian viewpoint, it is somehow contested or it's somehow compromised in the Newtonian notion of space and time. Now, how the things have evolved from that point to this point, it's an interesting and curious history. And in that history, there can be various stages. And the culmination part of it is how the Kantian notions of space and time were basically the zenith of Newtonian notions of space and time. The philosophy of Kantian philosophy is basically the how Newtonian notions of space and time, how they can be formulated. So in that context, you can see there are various debates, not only of philosophy, but mainly also the way we construct or construe empirical sciences in general or in particular science. Not only empirical sciences or the philosophy of empiricism, which is a part of how we can understand materialism and skepticism, which is the ground of Kantian understanding of how he just constructed transcendental idealism or Kantian notion of space and time. But it's also to be seen, if geometry is to be is seen synonymously with space, and space and is Euclidean or geometry is Euclidean, there are developments in geometry. So in previously also the notions of geometry, whether going from Euclidean geometry to non-Euclidean geometry, the transition from that, where you can say that space can not only be Euclidean, it can be non-Euclidean also in that sense. So there are various ways of imagining space. So this absolutization of Euclidean geometry in Kantian scheme. So, or in the way things have evolved, the way the frame, the background of Newtonian mechanics has been this geometry. But with the coming of non-Euclidean geometry, or with the coming of of how the empirical notions or empiricism as a philosophy, or emphasizing geometry, this is a very interesting chapter in how the notions of geometry or geometries, how they somehow interfaced with a certain empirical notions in that sense, and which somehow led to how we construct the relativities, the relativists, the for going from absolutization of things to the relativization of things in the Einsteinian scheme in the 20th century, and when how we constructed the theory of general relativity. So it's an interesting chapter in the how we can visualize, or how we can theorize things. The only point is that Iqbal is trying to see his how we understand time in some fundamental way, the ontology of time in that sense. So, if Newtonian worldview, or the epistemic foundations of Newtonian worldview can be seen in terms of Kantian notions of space-time, it's sort of emphasizing a certain Euclideanized version of space and time. So you can say, which has its worldview and sort of materialism it generates. So it somehow contests or conflicts with the medieval notions of or the theological notions of time and space, how we fundamentally view space and time, and notions of time as a property in that sense, whether the notions of time or the teleology associated with time has some order to it, some what I should say direction to it, some inevitability to it. There is a sort of causal order. So these are all notions which are discussed, which we will discuss. But the point is that there are some couple of observations of Iqbal which we are going to read with whatever we are going to read in that sense. And maybe before going to see it, so we are going to sequentially see and with intercept or interject our how we can go through it with some interjections with Iqbal, with some notions of space and time, which may not be, I'll just say, which may not be which may not be emphasizing which may just be the whole history of judging things in the background of empirical philosophy, or empiricism as a doctrine in that sense. So this is what we are going to see. So if we'll just I'll just see, so for example, fundamentally how do we see space? For example, the word space and time are both singular terms, so it necessitates us to ask whether does space exist, whether time exist, or what kind of entity is time, or what is space. So the problem of theory of time, before how we are going to see the Newtonian notions of time, they are contesting or contrasting some medieval notions of space and time, which had a strong theology attached to it. So we have to see the time, the way notions of time evolved from Aristotle to Kant in that sense. So for Aristotelian, who defined movement, if you construct time, so it can be the movement can be construed in terms of as an act and a potentiality or potency in that sense. So before, after Aristotle, maybe even in medieval times, the notion of time, whether it was created, or it's a property which has been created by God, or it's the time is an eternal property of matter in that sense. If you see debates of Ibn Sina, Ibn Taymiyyah, Ibn Rushd, you can see that property of time is sometimes seen in coterminity with the creator, the existence of the creator. But so you can continue with those debates from medieval discourses to the way Newton and Leibniz debated things. Newton debating via Barrow, his student, in a third person singular, in the third person way. And what Barrow says, that Barrow asks explicitly whether there was time before creation. That's whether the instant of creation is or is not the first instant, in that sense, whether time was created as a property at some point in time. So his answer is, before the world and together with the world, time was and it is. So space and time exist independently of material bodies or physical happenings, but not independently of God. So here comes the now the famous definition of how Newton defined time. So absolute time and mathematical time of itself and from its own nature flows equally without relation to anything external, and by another name called as duration. So all things are placed in time as to order of succession, and space in order of relation. This is how you can say. So time had a property which is universally there. Every point in space has the same time. So in that sense, so you sort of universalization or absolutization can be seen in that sense. But maybe in Newton's times, the way Berkeley contested infinitesimal as ghosts, he also just attacked these things as materialistics or atheistic concepts. For example, Newton added in to circumvent the critique of the attacks from Berkeley, the bishop. He says in the second column, Newton says, God is eternal and infinite, and by existing always and everywhere. He constitutes duration and space. So refuting these arguments of Newton through Barrow, Leibniz challenged the theory of absolute time in that sense. So but later maybe a lot of people are if you see things in that context, maybe people are saying even though Newton he famously tried to defend his notion of absolute space, or famous Newton's bucket experiment. So there should be an absolute frame of reference where you can to which you can refer things to. So maybe a lot of in that context, Leibniz theories of time as a rationalistic theory of causation can be rejected. Means time has, so if we just say in the Kantian way, time has three main aspects: duration, succession, and simultaneity. So there will be rules, and what are the rules in the theory of time in that sense? So if we say that time has to be understood in some topological sense, time has to be some, so fundamentally there can be some fundamental properties which can be seen. So for example, how we can define these duration, simultaneity. So if any of the two events, either one is before the other, or they are simultaneous. Either one event can be seen before the other, so it's a common sense, or they can be simultaneously. So if A is before B and B is before C, then if A is before B, B and B is before C, so then A is before C. So you have to have that succession is there in that sense, or transitivity is there. So no event can also be before itself in that sense. So events are before themselves, it's going to contradict this why I said first statement and the second statement means what I've said. So in that context, if you want to philosophically, so this is the point which Iqbal also says, I'll just connect it later, where he finds something some maybe puzzles which he is not able to resolve. So in that context, you can also see what is the philosophical import of these things. For example, so it means the way each event, if it occurs, it can occur recursively or infinitively in that sense, or the way eternal recurrence of Nietzsche, you can say, if you just take it philosophically. But how does it fundamentally, if we want to connect it, for example, if the Newtonian notions of space and time are absolute in that sense, and so there the world seems to be, for example, that this means if the theory rules out a beginning and indeed any asymmetry of past and future, the cosmic, the libs, so you can say it leads to sort of eternal recurrence in that sense. So it means that a Newtonian worldview consists of unending series of cycles which are identical except for their place in space, place in time. So, but if the theory rules out a beginning and indeed any symmetry of past and future cosmic evolution, the Leibnizian corrects the Newtonian. So in that sense, so if the beginning is, if the theory rules out beginning and indeed any symmetry of past and future cosmic evolution, the Leibnizian corrects the Newtonian one. Only one cycle occurs in that sense. So for Poincare, time should be so defined that equations of mechanics may be simple as possible. So for Maimonides, the medieval scholars, time is dependent on its existence, on the existence of motion, but not on anything else, including mind. And for Ibn Sina, time is what I should say, time does not exist, but exists in mind, because there is a notion of memory and expectation which go in how we just appreciate time in that sense. So the objectivity here seems to be compromised. So you can say duration, succession to causation, and simultaneity to reciprocal interaction. These are the words by which you can appreciate time. So now if we, so these are what I have tried to state, the way different notions of time and sort of bit of problems which can come. For example, Newtonian notion of absolutization of space and time leads to sort of eternal recurrence in that sense. You can construct or infer eternal recurrence from that, worlds being constructed again and again in a circular way. But if you take time as a relative, you can say world can be constructed as it was created once in that sense. So the argument can be more maybe what I should say, layered. So I'm just stating it only in that sense. So in 19th century theory of so this is what I'm trying to say. And in the same context, Leibniz defined time as order of non-contemporaneous events. So the question is, either contest this notion. So if time has parts, but how can order have parts? So this is a question mark. Either trying to refute Leibniz in that sense, not refute in that sense, questioning it. So time and space are the nature of elemental truths which can be equally possible and existing. So that which comprehends all that the places is called space in that sense. So here I'll just try to say so in the history of how we constructed space and how the map of space, which was seen to be Euclidean postulates with the coming of non-Euclidean geometry in that sense, where you can also construct equally consistent geometries can be possible, which may not be necessarily Euclidean. So prior to that, space was thought to be Euclidean, and Euclidean axioms were God-given axioms which have not to be tinkered with. And there is a famous axiom. So if you read Bertrand Russell's thesis on this foundations of geometry, or if you see, so there is this famously widely contested notion of axiom of free mobility, which means that spatial magnitudes can be moved without distorting shape. Or if you use the famous Kantian debate, the Kantian's left hand right hand argument, so which will let us explain how these things are bit, they can be more or less in that sense the argumentation is very much in some sense. For example, if there are two hands, what's the possibility that, so normally one hand can be on the other hand. The question is, what's the possibility of exactly transporting this portion of space on that portion of space? So it can be transported, but if you transport it like this way, only this way, you have to rotate it. So then only this portion of space can exactly be transported on this space. So in these simple argumentation, for example, this is this thing. So, but if you will do it this way, so it will, you have to translate it one by some angle. Then only this can, so the plane symmetry is not possible. So you can say, so axiom of free, so what is the possibility? You can exactly correspond one portion of space without the ideas of distinguishability or indistinguishability, or how you can map a portion of space vis-a-vis other portion of space with the notions of axioms of where spatial magnitudes can be moved without disturbing the shape. Here we saw in the right hand left hand argument, you can do the same thing, but via some symmetry, you have to rotate it by some angle. Then only you can do the thing. In this simple argumentation, you can say there have been various geometries which have been constructed, which are Euclidean, which are hyperbolic, which are spherical, or which is something called elliptical geometries. And each of these geometries can be axiomatized by spelling at the exact appropriate conditions on the concept of distance. So Riemann pointed out that it's possible to introduce metrics. Metrics means a space that lead to different geometries. You can have different geometries in that. And it was sophist Lie who proved that further there are further geometries where the principle of free mobilities does not hold. So you cannot exactly transport or map a portion of space to other portion of space. You cannot, the axiom of free mobility doesn't hold. So in that context, von Helmholtz, he's the person, he wanted to find those elements of Euclidean and non-Euclidean geometry which can be considered as common in that sense. So these entire notions have been, there is a term to it, and that's known as congruence or continuous transformations or congruent transformations. The way in your earlier classes in geometry you say whether two triangles are congruent or not, whether they are so exactly how you can have congruence of geometry. So with the coming of non-Euclidean geometries, So the point became, if the axiom of mobility doesn't hold from geometry to geometry, the question is how do these congruent axioms, how they can be understood, congruence relations understood when you go from geometry A to geometry B. So in the Helmholtz case, he wanted to see only the commonalities, the axioms, the congruence relations which hold both in Euclidean and non-Euclidean geometries. But there can be some geometries where their congruence relations may not hold. What does it all maybe import to, or what does it all say? And this entire thing maybe it led to something called notion of mathematical geometry and a notion of physical geometry. So notion of geometry and matter or space, how its properties may not remain same in presence of matter, and these congruence relations or metric relations, how they just you can see it in that sense. And the notions of what I should say causal theory of time or space and time. So in the previous lecture, not the previous lecture, I tried in some sense to show you the notions of simultaneity in the Einstein scheme, and notion of simultaneity in the Einstein scheme, which was seen in the notion of background causal order, and the Whiteheadian scheme of how he tried to interpret causality in a non-asymmetric way. So you can say, so in the same way, at the same time as Einstein, maybe there is another scientist, Robb and Whitehead, we are developing a comprehensive theory of time. Maybe this, maybe Iqbal is being more appreciative of Whitehead. So at the same time as Einstein, Robb and Whitehead was developing a comprehensive theory of time and space, it was, however, a basic disagreement with Einstein's critique of simultaneity. By the time Whitehead had developed a theory of relativity, there was an alternative to Einstein's, and apparently not in conflict with the observational data. While Robb, Whitehead, and Russell were engaged in philosophical and logical analysis of theory of relativity and space-time structure, the rapidly growing school of logical empiricism or logical positivism was doing rounds. Ms. Carnap, Philip, Reichenbach. So we are trying to just ground this debate of how we can construe simultaneity. So in the Newtonian notion of the time, which has some past, present, and future, which was contested by an observer's measurement of time, which is uniquely tied to his notion where he is in the space, measurement of time, and which somehow contests a sort of that causal order, the Newtonian order. So in that context, the Whiteheadian way of looking at things and the Einsteinian way of looking at things. So maybe Russell is also trying, so you can, there is a rapidly growing school which is something called a logical, which has been formulated in literature as logical empiricism in that sense, and logical positivism, you can say. So the logical empiricists have the what I should say, they have a reputation that they are being ahistorical. So they don't want to trace things to history. They want to see cause and effect in that in the sense of now. So you can the material causes in that sense, which cannot be necessarily dated to the past in that sense. So they also, maybe in that background, they also studied the work of Poincare and Einstein, and the way Einstein studied the work of Mach and Lib and other things. So in the same way, you can say Helmholtz and Mach. So the question is, so we are now going to ground this entire thing in the background of how empiricism as a doctrine, how we can just ground these space-time, the Newtonian space-time, the space-time as inferred from Einstein, special relativity, and the notions of simultaneity, how we can understand them how can we contextualize them. For example, if philosopher of science Kuhn says, when scientists are involved, because it led to a lot of revisiting some notions which were bordering on philosophy in that sense. Till things reached 19th, 20th century, the role of philosophy, role of logically emphasizing things. The school of thought has been so much influential that it somehow displaced that we don't take philosophy seriously in that sense. We take philosophy seriously only, for example, when scientists are involved in philosophical issues, being like philosophers in the crisis, they are engaging in inconclusive debates about fundamentals. When we cannot trace the epistemic foundations in some definitive way, so there is scope for dabbling or philosophically going through the philosophical gardens. But it discounts the fact that there can be scientifically inclined philosophers or philosophically inclined scientists in that sense. But if you are an emphasizing things, you want to catch and trace things now into the materiality of things and causality of things in that sense, in the definite sense, without a scope for multiple explanations in that sense, or without impending judgments in that sense. So how is objective knowledge of spatial and temporal relations, let alone space and time, possible? So it's a question in this thing. And what is the status of basic? So how do we axiomatize geometry? How does axiomatic geometry become empirical sciences? So we're coming to the way debates. So if we have to, if the axiom of mobility cannot be true for having those congruence relations when we have relations from one space to another space. So if you cannot transport or you cannot have congruence relation exactly satisfied between one we go from one space to another space in that sense. So the notion of geometry, how it's related with physics, or in presence of matter, how does the geometry, how can we explain geometry? So you can say, how does axiomatic geometry, which has become empirical science? So if we are trying to emphasize geometry the way Riemann did, the way Helmholtz tried to do, the way Einstein followed them, the way Kant also can be seen in that fundamentally, emphasizing the Newtonian notions of space and time. He was emphasizing Newtonian notions of space time and or Euclideanizing them, but the empirical tradition is strong enough. The way taken by Riemann, taken by Helmholtz, followed by Einstein. So Kant understood rightly that Newtonian principles as presuppositions of empirical reasoning could not be themselves derived from empirical reasoning of the same kind. But he mistakenly inferred that they can be inferred from empirical reasoning. So this is a doubt. So it's also not, so if Newtonian worldview leads to empiricism, but the thing is, but you cannot infer ab initio things from empirically. So why must metaphysics of space and time answer to the physics at all? Newton thought his notation, thought of, you can say it's the bucket experiment. So Einstein understood role of convention in connecting spatio-temporal concepts with the empirical observation and measurement. He gave empirical definition of simultaneity, and by the same stroke revealing the meaninglessness of the Newtonian absolute simultaneity and absolute time. Yes, you can say it that way. So, but before we are going to see it, so what we know normally called Newtonian thing is basically how we understood so Newton's mechanics, Newtonian understanding of space-time. Maybe it was there were a series of improvisations, particularly that of Euler and Lagrange, how they interpreted Newton. So the role of Euler was, in some sense, Euler tried to emphasize, but he tried to just somehow what I should make some amends. He was trying to make the Leibnizian relative notions of space and time, and the Newton, he tried to find some middle ground in that sense. And Leibniz, so for example, Euler articulation presupposes about was sympathetic to Leibniz's metaphysical views, but he was suspicious about action at a distance. So that's why he invoked the vortex theory in that sense. So Euler was to grant matters in which Leibniz had taken a priori positions based on metaphysical understanding of substance. Causality and nature of body were better seen as empirical questions. So the important point is that, for example, on the one hand, one might think of physics and metaphysics as competing sources of claims about the world, and on the other hand, in that context, we can see Leibniz clearly shows that both, despite making claims about nature of space and motion from substance and causality, that may be fundamentally at odds with each other. While in case, on the other hand, what I should say, physics requires that foundations in metaphysics. In that case, its principles have to be seen as superficial or uncertain. So the more important point is the first view is being exemplified by Descartes and Leibniz, who feel to reject ideas of Galileo and Newton that had no other basis than empirical evidence. While in case of Euler had empirically established principles of Newtonian physics with which metaphysics must come to terms with. So Euler wanted to empiricize things in that sense, and it's the metaphysics which has to come to terms with the empirical way of looking at things, rather than the other way around in that sense. So this is the way we read physics in our point. We have been reading Newtonian physics, the emphasizing of things in that sense. So maybe in that sense, Kant being influenced by Euler, so you can say there arose the tradition of reconciling Newtonian tradition with the Leibnizian metaphysics in that sense. But the point is the way the axiom of mobility, when it cannot, the congruence relations of spaces, when we go from one, the self-consistent non-Euclidean geometries are possible as are Euclidean geometries, but the point is their congruence relations may not necessarily hold. This led to a debate, something called Helmholtz and the empiricist critique of Kant, because Kantian empiricism has been seen a radical empiricism. It was trying to see Newtonian notions of Euclidean space-time, the empirical notions of Newtonian space-time in that strict sense. While the freedom which came with the non-Euclidean geometry and this other things, it's somehow, so the empiricism was not that radical in that sense, you can say. So in that sense, you can take the ideas of Poincare, who only saw the notions of these geometries as mere conventions. So these geometries can be seen dictated by the physics which is seen, or matter. So the physics sometimes dictates the geometries which you are interested in, or vice versa. So it's a matter of convention in that sense, or space whose properties we come to know by the group of congruence transformations. So you can say in that context, Riemann's view was philosophical view was forwarding a Helmholtzian empirical, empiricizing geometry point of view in that sense. So whatever I have said, this all was what I should say. This all comes to how Einstein constructed space and time in that sense. First in spatial theory, and how he constructed general theory of relativity. So which was later taken by positivists, which was hijacked by logical empiricists in that sense. So to the positivist, general relativity was no more or less the synthesis of post-Kantian ideas with the empiricist view. For Einstein, the concept of simultaneity does not exist for the physicists until he has a philosophy of discovering whether it is fulfilled in the actual case. It's a sort of pragmatic way of looking at things in an empirical sense. So Einstein had provided a coordinative definition of simultaneity where no exist before. So previously, simultaneity in the Newtonian sense, the notion of time was same for every point. But with the coming of this thing, special relativity, you can say the time was individual, but you can still rescue the empirical notions of simultaneity or metric simultaneity. So how we can construct simultaneous events, which is related with clocks being individual observers at given points. So what maybe people often talk of equivalence principle being. So what equivalence principle is more in the why is because it tried to just not absolutize but relative. You can see though all frames of reference, the notion of absolute frame of reference, its futility can be seen in the sense that how we can make equivalence of different frames and in an evolving framework. For example, instead of Einstein, instead of analysis of evolving role, the concept creates an evolving role of body in theory as well as practice. So taking electrodynamics and later extending into general relativity, the role of Einstein was that how if you cannot have an absolute frame of reference, how you can relatively construct things in an evolving way. For example, whether an accelerating reference frame, whether how you can annul or how you can extract a given reference frame, which has the properties of the same as if we are referring things to the absolute frame of reference. So whatever I have said in that sense, now I'm coming to Iqbal. There are some couple of observations, interesting observations of Iqbal. Whatever I have said. So I'll again come, for example, Iqbal says that so these are very interesting observations. So before, we have not up to this time come up to what we are seeing time and space only as being empirically constructed or as being constructed in operational terms or as being constructed in our how measurement schemes. In the medieval notions of space and time, how they or notions of time seen. So Iqbal is seeing things. I believe so. This is important. I believe that ultimate character of reality is spiritual, but in order to avoid a widespread misunderstanding, it is necessary to point out that Einstein theory, such as scientific theory, deals only with structure of things, throws no light on the ultimate nature of things which possesses that structure. This is the discomfort of Iqbal. So he's Iqbal in worldview is a sort of a religious worldview. It's a medievalistic. He wants to just see the ontic necessity of things, but whether the uh, whether the causal necessity of trying to locate notions of time in some causal order. In case of Einstein, in an indirect way. In case of Newtonian things, you can just see the order, the past, present, and future. But Einstein trying to metric or empirically from the arguments of electrodynamics, trying to have a measurement of time but in operational terms. So whether that teleology has some purpose, or is it related with the whole of cosmic order, or they are not interesting questions. Maybe they have not been addressed. So this is the discomfort. So Einstein theory, which is as a scientific theory deals only with the structure of things, throws no light on the ultimate nature and of things which possesses that structure. The philosophical value of theory is twofold. First, it destroys not the objectivity of nature, but the view of substance as simple location in space, a view that led to the materialism in classical physics. So on the one hand, is appreciative of this thing, that the Kantian notions of space and time, the radical empiricism of Kant, when interpreted through Newtonian notions of space-time, the materialism which was associated with has been somehow contested, but somehow is not satisfied with the ontology of space, fundamental question. What does it mean in that cosmic sense? So here in the coming, so Einstein and relativity presents one another observation, presents one great real difficulty, the unreality of time. A theory of time which takes time to be a kind of four dimension in space must, it seems, regard that future is something already given as indubitability fixed in past. Time as a free creative movement has no meaning at all. It does not pass. Events do not happen. We simply need them. So maybe Iqbal is not totally. He himself later says that we as laymen cannot understand relativity. I'll just come to it. But the point is, he is contesting the causal order, which is trying to, which Einstein is trying to somehow. Even though the causal order is not there, it can be contested, but somehow Einstein is also in the very vocabulary of it. They are trying to rescue that sort of innate causal order in that sense. But Iqbal is trying to just say time as a free creative movement. So at every moment in time, so it has some creativity attached to it. So there is not innate inevitability which can be inferred from this relativity in philosophical sense. Not technically in that sense. Maybe maybe Iqbal may be wrong in the sense that he is trying to say a theory which takes time to be a kind of fourth dimension. So time is not in that sense spatiality attached to. You can see, we normally go to complex plane in mathematics. We imagine it in that space, what I should say, hyperbolic space in that sense. But you can see time as a parameter in that sense, but it's not a time as a, what I would say, a kind of four dimension. You have to see time as a parameter rather than in terms of a spatial dimension. But further, for example, Iqbal says that it's obvious. It must, however, be forward, therefore neglect certain characteristics of time as is experienced by us. It's not possible to say the nature of time is exhausted by the characteristics which the theory does note in the interest of systematic account of those aspects of nature which can be mathematically treated. So nor is it possible for laymen to understand the real nature of time, Einsteinian time. So Einstein time is not a Bergsonian duration. Nor can we say it's a serial time. Serial time is the essence of causality as defined by Kant. So this is what, so Iqbal is So he being a philosopher or being a poet, so he has different concerns why to understand relativity. His understanding of relativity is more, he wants to sort of just his worldview, religious worldview. He wants to see time in that sense, you can say it. But it seems somehow been contested, or it's somehow been contested the way people interpret relativistic notions of time and space. Although in the Whiteheadian notions of how he constructs time, we can have observer creates reality while observing things. So it's not as if you assign things. It's co-evolution of observer and observed in that sense. But if you are trying to, basically Einstein, Iqbal is trying to, in the 1990, 2030, he's trying to fight a certain hijacking of logical empiricist or logical positivists, trying to emphasize the debates or the developments of the way relativity have been understood by people like Reichenbach, Carnap, whole the school, which is it. So in that context, if I'll just maybe somehow conflate it, not in the how, if you want to see Iqbal through Ibn Arabi's concept of time in that sense. So for Ibn Arabi, so he quotes, so if I'll just maybe forward what Iqbal is basically the notions of time as seen in Quran or as seen in theology. For example, Ibn Arabi can be one of the philosophers or theologians. So for example, he says in Hadith Nabi, God says, I have a time which is called Waqt with God, which mystic poets present as if Muhammad's privilege of communion with the eternal, while Rumi, inspired by the tradition, focusing on Prophet's Waqt. So Ibn Arabi, being contemporary mystic and philosopher, so he just captures this canonical tradition of Hadith Qudsi, which says, I am time Dahar, while tradition and its variant, God is time Dahar as the starting point. He taught all existence is one existence, and created things in nothing, but the created things are nothing but a reflection of creator's existence. So Ibn Arabi created the union of time that linked three notions. One is Zaman, the other is Dahar, and third is Waqt. So nevertheless, if I quote this one of the scholar, so how he sees things, Gerhard Brunning, he says, nevertheless, he thought in original in a way that it combines, Ibn Arabi's notion of time combines atomistic notion of time as Waqt and theological version of time as Dahar, with a partially cosmologically and partially relative understanding of time as Zaman. Know the relation of eternity, Azal, to God is the same of relationship of time, which is Zaman. So this notion of Zaman, Makan, Dahar, Waqt, so it's also very interesting in the etymology of words. When you talk of space and time, you talk of space and time. With the invocation of relativity, we have space-time. So you can say it's interesting in the etymology of this Persian or Arabic things. So you have space-time, it's always space-time, not space and time or space or time. So you cannot imagine in the common vocabulary, one at the expense of the other. But and further, there can also be not only one spaces, and there can be many spaces. There cannot be one time, there can be many times, and there can be many space-time orders. So whatever I have said, so if we'll just, I'm just quote some further few of the things how we can appreciate these medieval notions of with these notions of space-time, because I'm conflicting it basically, how this Einsteinian notions of space and time, it has a background discourse of emphasizing geometry against the radical empiricism of Kant, but the empiricism which was mellowed down when we take axiom of mobility, that congruence relations cannot be seen when different, they cannot exactly hold between different spaces or different times. So it led to a certain viewpoint which helped us to what I should say, how constructed space and time, special relativity, and how constructed general theory of relativity, even though it was little hijacked by taking emphasizing things more in the way logical empiricists do or logical positivists do. So this all thing I'm conflicting against this Iqbalian notions. Iqbal feels that this entire notion, it doesn't talk something fundamentally about time as a free creative movement, or time as being appreciated by medieval theologians or in terms of zaman, dahar, or waqt. Or if I'll quote a modern day mystic philosopher, so I'll just quote his words. I hope I can translate them without the benefit of without things getting misunderstood or in that sense, because I'm translating from Urdu. So for example, Ahmad Javed says in his philosophical themes of Iqbal, in one of his lectures on space and time, he says, time एक एतबार है, अकल में मेटाफिजिकल तलाश, अकल में मेटाफिजिकलिटी की तलाश, वक्त एक एतबार है. अगर ज़माना ऑब्जेक्टिव एंटिटी है तो साबित नहीं किया जा सकता है. अगर ज़माना ऑब्जेक्टिव एंटिटी है तो ये साबित नहीं किया जा सकता है. अगर ये सब्जेक्टिव ऑर्डर है तो इसको इस लिम में लाने के लिए अक्ली ज़राए एक हैं. वजूद अपनी कॉस्मिक ऑर्डर में मेटाफिजिकलिटी रखता है ताकि सूरत के साथ हकीकत की मुताबिकत हो जाए. So time, the notions of time are not absolute in that sense. They can be subjective, and if they all have to be taken as objective, you have to relate. You have to have a definite knowledge scheme or knowledge episteme, which cannot be divorced from that metaphysicality, where the form and the reality can somehow, the way Aristotelian think, the form and the act and potency can get unified in that fundamental sense. So it's not possible. The notion of time is subjective. If we have to make it objective, so you have to, the act and potency has to be seen through a certain metaphysical notions, which only religions speak of. So ज़माने के दरिया में उतर कर भी वजूद के दरिया में गवासी करनी होगी. ज़मान वजूद का हाल है. So if you have to ज़माने के दरिया में उतर कर भी वजूद के दरिया में गवासी की जाए. So if you have to enter into time. Time is not in that fundamental property, but while entering time, you can have feeling of what existence is, or what wujud is, what is the fundamental thing. The notions of time will help us you coming to that, closer to that fundamental reality, fundamental metaphysicality of the things. Zaman wujud ka hal hai. So what's apparent? Time is the apparent of that real. You can see it, and that real may be God, or that's the ultimate reality or unity of being in the Arabian sense. And the third sentence he says, हाल, मुस्तकबिल और माजी की पैमाइश ये एक शऊरी वक्त है। वक्त की हकीकत मेरे अनफुस की है, ये कि आफा की हकीकत है। वक्त अपनी अनफुसी हकीकत में वक्त अपनी अनफुसी हकीकत में हकीकत है, न कि आफा की सूरत में। अपने नफ्स में जागो, वहाँ वो खालिस हकीकी वक्त है। So you can say past, present and future are the measurements of time. So वक्त मेरे अनफुस की हकीकत है. So time is the subjective reality of myself. टाइम, हाँ, ये एक आफा की हकीकत है. एंड व्हेन यू ट्राई टू पॉन्डर इनसाइड, सो outside it can be subjective. When you try to see it through your own self, you can come to that the universal meaning of time, which you can see in relation to creator or God. और अनफिसी हकीकत में हकीकत है, न कि कोई आफा की सूरत. अपने नफ्स में झांको, वहाँ खालिस हकीकत हकीकी वक्त है. You go and try to see your realities of inner self. So here this quote from Rumi may be more poignant. So he says that I went to see God in the universe, and I found myself only. But while I peeped into myself, I saw God only. Maybe this is the thing. So here at this poignant end, I'll just end it and I'll continue it again. These couple of more paragraphs to just see how this Einsteinian thing, how these things can be seen in a better way in the coming lecture.